Here are 6 problems I'd like you to try now, which are based on the type of problems we just did in the lecture. You don't have to write over 1 on these questions, and I'd prefer you not actually, but if you want to, you can. It's no problem. But I would like you to show your work. So show, for example, on this first question, show here x is equal to like something times something, or something divided by something, and then on the next line write x equals to the number that the answer is. On these 6 questions, I actually made them so you don't really need a calculator. You shouldn't need a calculator to answer these. The next 6 I'm going to give you, you will need a calculator, but for these ones you shouldn't. So let's, I'd like you guys to pause the video now and try these, and we'll take them up together after you try them yourself. Alright, pause the video. Alright, so let's tackle these now. On this one here, like I said, it's okay to put over 1 in your head, but let's just not write it. If I were to put over 1 here, I'd write this, right, 4 over 1. And then I'd have 4 over 1 as a fraction equals 12 over x as another fraction. And I look at my crosses. Here I have 12 and 1, here 4 and x. So I know I multiply 12 times 1 divided by 4. But 12 times 1 is just 12, right? So x is really just 12 divided by 4. And this is what I meant by showing the work. And then the answer is x equals 3, because 12 divided by 4 is 3. How about this one? Well, if I were to put over 1 here, I'd have x is 11 times 5 divided by 1, which is the same as just 11 times 5, right? And so our answer is 55. On this one, we have 4 over 1. So x is 88 times 1 divided by 4. In other words, x is just 88 divided by 4. What is 88 divided by 4? 22, right? Okay. Let's imagine we put over 1 here. Then we would have x being equal to 23 times 5 divided by 1. But there's no use in writing divided by 1 since it doesn't change anything. 5 times 20 is 100, 5 times 3 is 15, and 100 plus 15 is 115. So that's our answer there. What about this one? If I put 9 over 1, x is 72 times 1 divided by 9, which is the same as just 72 divided by 9. So x is 8. Alright. And the last one, if I put 7 over 1 here, x is 7 times 7 divided by 1. In other words, just 7 times 7. So x is 49. Okay, so that completes those ones. I hope you got all those right. Now let's take a look at another set of 6 questions. Now I'd like you to try these 6, and you will need a calculator for them. So, and try not to write over 1. If you want to, you can, but try not to. Alright, so pause the video now, and we'll take them up in a second. Okay, so the first one, imagine that 34 there is put over 1. X would be 19 times 1 divided by 34. Therefore, x is just 19 divided by 34. And we could leave our answer like that, but let's take it to a decimal and round it to the nearest hundredth. 0.56. I guess there's one thing I should actually mention here. And notice I write x equals 0.56. Technically, that's not really correct. You know the symbol I really should write there is approximately equal, right? Do you know that symbol? It looks like this. It's like a... Right? This means x is approximately equal to 0.56. Because 19 over 34, when you type that in your calculator, you see it's not 0.56. It's, what is it again? 19 divided by 34. It's 0.55882352, etc. And so this is not, it's not true that x is equal to 0.56, because that decimal I just read is not 0.56. But I think writing this symbol here is being a little bit too picky. Like it's too, it's nice to be accurate and all that, but we know that the answer is an approximation, okay? And since I've asked to round to the nearest hundredth up here, it's all right to write equals, okay? If you're not really following the reason I'm talking about this, don't worry about it too much. I'm just saying that the true answer is not 0.56. 0.56 is very, very close to the true answer, but and it's really just a rounded value to the true answer. And in trigonometry, we have to accept that, because lots of trigonometry, the values, they're decimals that go on forever, and we have to round them to a certain accuracy. And we just, if we want more accuracy, that's fine. We just round to the nearest maybe thousandth or 10,000th or millionth, whatever you like. You can get as much accuracy as you want, but you do have to chop off the number eventually. All right, that's enough of that. So we're going to write equals all the time there, even though if you're very, very picky and technical, you should write the approximate sign there. Good enough. X here, this times this. That's all there is to it. 97 times 33. And I take my calculator for that. 97 times 33. 3,201. Here, x is going to be this divided by that. 56 over 557. What about that? 56 divided by 557. If I round that to the nearest hundred, I get 0.10, 0.10. Okay. Here in this one, x is going to be this times this. 2.2 times 4.2. Go to my calculator. 2.2 times 4.2. 9.24. That's an exact value there. We don't need to round. In this one, x is going to be this divided by that. 0.2 divided by 0.09. What do I get? 0.2 divided by 0.09. 2.22 when I round it to the nearest hundredth. Finally, x is this times this. 1.3 times 7.04. And that's going to give us 1.3 times 7.04 equals, well, if I round that to the nearest hundredth, I get 9.15. Okay, so I hope you understand solving ratios now, because these are the kind of ratios that are going to come up a lot in the course. And that's really all the algebra you need to know to be successful in this course, is just how to solve these little tiny algebra equations. And you'll see pretty soon why we talked about this, because in trigonometry, these kind of this style of equation happens all the time. Okay, so we're finally done with that, and we're actually going to start on triangles now, reviewing some stuff on triangles, and let's get to that now.